All right, in this video we're solving inequalities. We're going to try to isolate x here in example A, but x is, of course, in the middle of a compound inequality that has three sides. So what we do to one side, we have to do to all three sides this time. So the first thing we're going to do is apply the addition property of equality by subtracting off 2 from all sides of the inequality. So 6 minus 2 will give you 4. That'll be less than or equal to 2x. The 2's cancel out here, and you'll have less than or equal to 10 minus 2, which of course is just 8. Then that's 2 times x, so to get rid of the 2 that's attached to x there, we'll use the multiplication property of equality, and we'll divide all sides by 2. Now from here, 2 goes into 4 2 times, 2 goes into the 2 here next to the x 1 time, leaving you just 1x, and then we'll have less than or equal to 8 divided by 2, which of course is 4. And now the way this statement is read is that it's saying x is between 2 and 4 inclusive. If we drew it on a number line, it would look like this. We'd have 2 and 4, and x would be in between here, between these 2 points. We'd use square brackets because of the equal signs in those inequalities. So to use interval notation, we'd actually write this as 2 comma 4 surrounded by brackets. All right, that's example A. Let's look at example B. So similar thing, we want to isolate the x here. So I'm going to subtract 1 from all sides of the inequality first. So 0 take away 1 is negative 1. These ones will cancel out. Then we'll have negative 1/2 times x less than 1 minus 1, which is 0. All right, now this negative 1/2 is multiplying x. To get rid of that, I can multiply all sides by the reciprocal, negative 2 over 1, right? That will get rid of the fraction that's attached to x. However, then I'd be multiplying the inequality by a negative value. Whenever you multiply or divide an inequality by a negative value, you must flip the inequality symbols. So I'm going to put this negative 2 over 1 around the entire inequality, but when I perform the multiplication, I need to remember that I basically need to flip those inequality signs. So negative 2 times negative 1, of course, is going to give you positive 2. That less than symbol will become a greater than symbol. This negative 2 over 1 will cancel with the negative 1/2, leaving you just x. The inequality will become greater than, and 0 times anything is just 0, of course. So the statement here is perfectly correct, but it's written a little funny. We normally would put the statement in the reverse position. So what I'm going to do is just flip this statement around. Just make sure that, for example, look at this inequality symbol on the left. That point is facing x, right? We need to make sure that stays the same when we flip the statement. Likewise, the point here is facing 0. We need to make sure that stays the same as well. So I flip it around. I'll have 0 is less than x is less than 2. So that's the equivalent statement, just written in a proper way. And then if I wanted to do the graph, we'd say, okay, that's basically saying that x is between 0 and 2 on the number line. And so we're saying this is where x is located. We'll use round parentheses here to surround that interval because, of course, we do not have equal signs in our statement. So the answer in interval notation is simply that x is between 0 and 2. Okay, let's look at example C then. For example C, it looks like we have a lot of distribution to do to start the problem out. So I'm going to go ahead and distribute by putting x into the equation here on the left. So x times 9x is going to give you 9x squared, and then x times negative 5 is going to give you negative 5x. Then you'll have less than or equal to. I'll square this binomial. So we'll square the first piece. That'll give you 9x squared. Then I'll square the second piece, that gives you plus 1. And then remember, we actually take the product of the two terms and do twice that to use the shortcut squaring procedure, right? So negative 1 times 3x is negative 3x, but we're going to do twice negative 3x, so we'll have negative 6x. So that's basically how you square it if you want to use the shortcut squaring procedure. Now from here, we basically have a quadratic on both sides. So let's bring everything over to one side and set the inequality equal to 0. So we'll do minus 9x squared minus 1 plus 6x. We'll do that to both sides. So we'll end up having minus 9x squared plus 6x minus 1 on the left, right? And all the terms on the right will cancel out. On the left side, we'll have x squareds cancel out. We'll end up having just 1x minus 1 is less than or equal to 0. Okay, from there, we'll simply solve by saying that x is less than or equal to positive 1. And with that statement in mind, we can draw a little graph. If x is less than or equal to 1, it's saying that, okay, if here's 1 on the number line, x being less than or equal to means all of this, right? Including 1. And that goes down to negative infinity on the lower end. Okay, so from the graph, we can see that our answer for the inequality is from negative infinity up to positive 1. We're going to include the positive 1, so we use a bracket on the right-hand side of the inequality.